Hello friends, welcome to Susan and John MathTube. In this lesson, we learn how to find the Laplace inverse using partial fractions. So, you have used partial fractions in integration. Similarly, we are going to use partial fractions to find the Laplace inverse. The main part will be how to convert a function into partial fraction. Once you are very clear with that, you can be very happy because there will be 3 questions in exam. The first one will be from Laplace, the second one will be from Laplace inverse, and the third one will be solving a differential equation using Laplace transform. And when we solve differential equations, we always end up with partial fraction method. So you have to be very good with this method for the sake of solving differential equations. Okay, now look at this. Partial fractions are decomposition method. Okay, now look at this. Partial fractions or decomposition method is classified into 3. Actually 4, but we will learn only 3 methods, and the 4th method is nothing but division. Okay, look at this. Can you see the function? 3s divided by s square plus 2s minus 8. Actually, this can be factorized. It can be written as s plus 4 times s minus 2. Now look at this. If you have any trouble in factorization, you can remember your calculator. All you have to do is you have to use the solve polynomial option and feed this polynomial as an equation. And you will get the roots as minus 4 and 2, so that the factors will be s plus 4 multiplied by s minus 2. And one very important thing, in general when you have a quadratic equation or a quadratic polynomial, let's think about this quadratic polynomial, and let's imagine you converted it into an equation and you solved it using a calculator. And let's say the calculator is giving you the roots alpha, beta. So the factorized version will be a multiplied by x minus alpha times x minus beta. Here the value of a is 1, so we simply write s plus 4 s minus 2. But in general, don't forget this a multiplied by x minus alpha x minus beta. Anyway, this is type 1. I'll show you the difference between type 1, type 2 and type 3. Can you see the first expression? 2x plus 1 by x minus 1, x plus 3, x minus 2. The degree of all the factors are 1. And the actual method is you will equate it to a by x minus 1 plus b by x plus 3 plus c by x minus 2. But I go for a little bit powerful method, that is called method of suppression. So what we do is, once you identify the given function is in type 1, how do you recognize type 1? Type 1 means the denominator will have factors with order 1, with power 1. Can you see? This is not type 1. Can you see? This is not type 1. And in type 1, the easiest method is suppression method. That is, instead of writing a by, b by, c by, all you have to do is you just write like by x minus 1, by x plus 3, by x minus 2. And then you look at the factor in the denominator. Tell me, when will x minus 1 vanish? X minus 1 will become 0 when x is equal to 1. Now all you have to do is you have to plug in the value x equal to 1 everywhere else other than x minus 1. You plug in the value x equal to 1 everywhere other than x minus 1. So you'll get 2 times 1 plus 1 divided by 1 plus 3, 1 minus 2. You simplify this and write the value here. Now look at this factor, x plus 3. The question is, when will x plus 3 become 0? When x is equal to minus 3. and you plug in the value x equal to minus 3 everywhere other than the factor x plus 3, and you write that value here. And finally, look at the last factor, x minus 2. When will x minus 2 become 0? When x equal to 2. So you plug in that value everywhere other than x minus 2. Now, for type 2 and type 3, we will follow the stereotyped decomposition method or the partial fraction method. So, type 2 is easy to recognize. You will see that one or more factors will have power more than 1. Can you see? This one is x minus 1 the whole power 1. So basically it looks like type 1. It is type 1. But look at the next factor. There is a whole square. So this is not type 1. This is type 2. And what we do is we go for the stereotyped method, the partial fraction method. We will write, let it be equal to a divided by x minus 1 plus b divided by x plus 2 plus c divided by x plus 2 the whole square. If you are wondering why I am writing like this, I have kept a video on partial fractions. You can search in the playlist. You can search in the playlist about partial fractions and decomposition, and you can learn the logic why we are assuming like this. Anyway, your job here to get marks is very easy. Find A, B, C by plugging in any number that you like. Okay, now look at this. Clearly type 2. Clearly this is type 2 because, can you see? This looks like type 1 because the order is 1, the power is 1. But can you see a whole square, whole cube? So the answer will be, or your assumption will be, let it be a by x minus 1 plus b by x plus 2 plus c divided by x plus 2 the whole square plus d by x minus 3 plus e by x minus 3 the whole square plus f by x minus 3 the whole cube. Now this is a headache because you have to find a, b, c, d, e, f, and then only you will be able to take Laplace inverse. The last part is so easy because instead of taking Laplace inverse of this, you are going to take the Laplace inverse of each function, and you already know the formula. Now clearly type 2 because can you see the factor x square? So we assume a by x plus b by x square plus c divided by x minus 4. Now comes the last type, type 3. In type 3, you will always see a quadratic. What will you see? A quadratic factor. And the most important part of this quadratic factor is, it is not like the quadratic I showed you earlier. Look, in the first question we had a quadratic and I used my calculator, and when I solved, I got some real numbers. But in this question, if you use a calculator and try to solve it, the roots will be complex numbers, or rather we will not be able to factorize this in real number system. In the next semester you will learn applied mathematics, you will learn complex analysis. In that case you will be able to factorize. Anyway, this cannot be factorized into real factors. Okay, so the assumption is, look, this is type 1, so a by x minus 1. This is type 2, so b by x plus 2 plus c divided by x plus 2 the whole square. Now tell me the next two letters, a, b, c, d and e. So I am going to write dx plus e divided by x square plus 4. Once more I will repeat, there is a specialty for this quadratic factor. The quadratic factor cannot be factorized into real factors. That means if you solve it with a calculator, the roots will come imaginary. So same thing, I'll show you one more example. This is type 3, absolutely type 3. So look at the first one, a by x plus 1 plus, tell me the next two letters, bx plus c divided by x square plus x plus 1. Now look at this, the essence of the chapter is only this much, but there are some special problems. And I want you to work out the problems, as soon as the video is over. I'll tell you how to tackle the problems. I'll work out one or two problems and I'll show you a few problems that come regularly, especially inside the differential equation. Anyway, look at this. I saw a quadratic, but I know this is not type 3 because I am able to factorize. We have 3s divided by s plus 4 times s minus 2. So type 1. In type 1, we don't go for the actual decomposition method. We go for method of suppression. So what did I do? I'm going to write this as something by s plus 4 plus something by s minus 2. And you might be thinking, is it always plus? Yes, it is always plus. Because if it is negative, automatically this value will become negative. Okay, now tell me, when will s plus 4 become 0? When s equal to minus 4. And you have to plug in s equal to minus 4 everywhere other than s plus 4. So what will I get? 3 into minus 4 divided by minus 4 minus 2. So that will be minus 12 divided by minus 6. That will be 2. And when will the second factor, I'll use another color, this becomes 0? When s is equal to 2. Now I'll put s equal to 2 everywhere other than s minus 2. So what will I get? 3 into 2, that is 6, divided by 2 plus 4, 6. So 1. Done. Decomposition done. Now look at this. Now I'm going to write the question once more. We have to find Laplace inverse of 3s divided by s square plus 2s minus 8. But just now you decomposed it. And instead of this function, you can write 2 divided by s plus 4 plus 1 divided by s minus 2. You know that Laplace inverse has a linear property, so you can split it. So you'll get Laplace inverse of 2 divided by s plus 2 plus Laplace inverse of 1 by s plus s minus 2. If you know the formula, you can write the answer directly, or you can use the inverse shifting property. Do you remember the inverse shifting property? If you have Laplace inverse of f of s minus a, you will write e to the power at and take Laplace inverse of f of s. So this will be, this 2 goes outside and e power minus 2t. I know the formula directly, plus this is e to the power 2t. So that's it. Now let's go for another question. So look at this. Find the Laplace inverse of s square plus s minus 2 divided by s plus 3, s minus 2. Come on. What's the first thing to do? You can see that it is type 1. You have to identify the type. It is type 1 because the degree is 1, degree is 1, degree is 1. Now this is so easy. Don't go for the stereotyped partial fraction method. I will recommend the decomposition using suppression. So you write something divided by s, something divided by s plus 3 plus something divided by s minus 2. And when will this become 0? When s equal to 0. And you plug it everywhere else other than here. So you get 0 plus 0 minus 2 divided by 3 multiplied by minus 2. So you get 1 by 3. Now when will this become 0? When s equal to minus 3. So minus 3 the whole square, minus 3 minus 2 divided by minus 3, and you should not substitute it here. Minus 3 minus 2, that is minus 5. So the numerator is 4 divided by 15. Okay, now what about this? S equal to 2. You plug it everywhere other than s minus 2. 4 plus 2 minus 2 divided by 2 multiplied by 5. That will be 4. Yeah, this will get cancelled. So 2 divided by 5. That's it. That's it. Now we need the Laplace inverse of this. This is the question, right? But instead of this, you take the Laplace inverse of this side because both are equal. And now split it, find the answer. Now let's go for one important question. So what do you think about it? Is it type 1 or type 2 or type 3? All you have to do is, when you see a quadratic, use your calculator and try to factorize. Oh, I'm able to factorize it into real number. I mean real factors. Because when I use the calculator, I got real numbers as the root. So I can write this as s square minus 10s plus 13 divided by s minus 7, s minus 2, s minus 3. 100% type 1. I'm not going to waste your time by doing that. What about this? You try it. Now let's go for another one. Okay. This question is very important. There is another method also, it's coming up in the next video, that is convolution method. But this question is very important if you are using partial fraction method, because some people waste a lot of time by using type 3, because this is obviously type 3. Obviously this is type 3. Now when you use partial fraction, I forgot to tell you one very important thing. That is, you should always check the degree of numerator and denominator. And the degree of numerator should be less than degree of denominator. Otherwise, this type 1, type 2, type 3 will not work. You will go for the division method and convert it into type 1 or type 2 or type 3. Okay, anyway, this is obviously type 3, but we have a loophole here. Can you see the entire function is made up of s square? We have learned this in first semester in Leibniz rule in integration. Can you see the entire function is made up of s square? It's not a mixture of s and s square. It is not like what you call, it's not like this. If it is like this, we cannot use this trick. So all you have to do is, you have to decompose 2u minus 1 by u plus 1 multiplied by u plus 4. All you have to do is, you have to decompose 2u minus 1 by u plus 1, u plus 4, and I will do that. It is type 1. It is type 1. You can save a lot of time if you do this method. And once more, let me tell you why this is type 1 and not type 3. It's because everything is made up of s square. If it is a combination of s and s square, you cannot do this. Okay. Now, when will this become 0? When u equal to minus 1, you will get some number here. And when will this become 0? When u equal to minus 4, you will get some other number here. Now, replace every u with s square so that you will get the decomposition of this function, s square plus 1, s square plus 4, and you know the values, and take Laplace inverse on both sides. I'll give you one more question like this so that you can practice. Yeah, not one, two questions are waiting for you. So can you see? This function is made up of s square and s square, so the trick will work. Actually, this is type 2 and type 3. If you don't know this trick, you're going to be in big trouble. You'll be using type 2 and type 3. And think about it, you'll be writing this as a by s plus b by s square plus cs plus d by s square plus 1. And we will waste a lot of time calculating a, b, c, d. But now let's go for this amazing method. Since the function is made up of s square, s square, s square, s square, everywhere there is s square. So all you have to do is you have to decompose 1 by u into u plus 1, which is obviously type 1, and decompose it and replace every u with s square, take Laplace inverse. Now the same thing for you, but one more thing, in the next video we will learn convolution, and once you know convolution, you might find convolution method more easier than this for this problem. Okay, now let's go for type 2. Now, how do I know this is type 2? Very simple, because there is a linear factor and a linear factor with higher power. So, same method. So, I'm going to assume let 4s plus 5 divided by s plus 2 times s minus 1 the whole square is equal to a by s plus 2 plus b by s minus 1 plus c divided by s minus 1 the whole square. Now, the actual decomposition method goes like this. You have to multiply throughout by, I'll mark it with purple, you have to multiply throughout by that factor. So tell me what happens if you multiply numerator and denominator with the same quantity. you get the numerator. Now what happens if you multiply this by s plus 2 times s minus 1 the whole square plus b multiplied by s plus 2 s minus 1, because 1 s minus 1 will get cancelled, plus c multiplied by s plus 2. I hope you are working along with me, because unless and until you work out, you will not be perfect with the method. Now look at this. You can choose any number for s and solve for a, b and c. You can choose any number for s and solve for a, b and c. But still choose the best. Choose the best. And if you're wondering what is that best number, look at the denominator of this question. You will see two factors. So the first number I'm going to choose is s is equal to minus 2. And why I call it the best is because when I plug in s equal to minus 2, a few terms will vanish. So what is 4 times minus 2? Minus 8 plus 5 is equal to, what is minus 2 minus 1 the whole squared? That will be 9a. Done. Because this will be gone. Minus 2 plus 2 will be 0. Minus 2 plus 2 will be 0. So did you understand why I called it a good number? So a will be equal to, how much is this? Minus 3. So you will end up with minus 3 by 9. 1 by 3 negative. Yeah. Now I have another good number waiting. Put s is equal to 1. And why is it a very good number? Because when I plug in s equal to 1, I can see this term and this term will vanish. Okay, so 4 into 1 plus 5, that will be 9, is equal to, this is gone, so 1 plus 2, 3, 3c, so c is equal to 9 by 3, that will be 3. Now we have to solve for one more quantity. We have a and c, so you can use any random number like s equal to 0, or you can equate the coefficient. Equating the coefficient will be difficult for the average and weak students, so I prefer putting some random number and solve it patiently. So I'm putting a random number s equal to 0, so 0 plus 5, that will be 5. 0 minus 1 the whole square, that will be a itself, plus 2 into minus 1, that will be minus 2b, and then 0 plus 2, that will be 2c. Now what you do is you plug in the values of a and c and find the values of b, because we already know a and c. You can find the value of b. Anyway, you can try that yourself, and at the last you have to take Laplace inverse. The method is similar. You find a, b, c and find the Laplace inverse. If you have any confusion in partial fraction, I'll strongly recommend you go to the playlist and find a video related to, there are 3 videos for type 1, type 2, type 3. If you have difficulty in type 2, just find that video and settle it. It's something which you learn in your plus 2. In type 1 you will not have any difficulty, because we didn't go for the stereotype partial fraction method. We had a shortcut method of suppression, so things were so easy. But in exam they can ask type 1 or type 2 or even type 3, because I told you in the beginning, when we do differential equation, this will pop up. So make sure you solve for b. And anyway, there is one more method, that is equating the coefficients. You can try that also. Because if you use that method, I can see that I'll get a plus b is equal to 0. So a is equal to minus b, or we need b, right? So b is equal to minus a, so b equal to 1 by 3. So easy. You can try to solve it here. You'll get the same value, b equal to 1 by 3. Now it's almost time to conclude the video. So I'll show you one more question. This is obviously type 2, because the denominator has a linear factor with higher power. So you have to assume s squared by s minus 1 the whole cube to be a by s minus 1 plus b by s minus 1 the whole square plus c divided by s minus 1 the whole cube. And when you solve it, you'll be a little bit disappointed because there is only one good number, that is 1. When you plug in s equal to 1, you'll get one of the unknowns very easily, and for the remaining part you may have to plug in s equal to 0, s equal to 5, equate coefficient, but solve it patiently, Okay, now this one also you can solve, same method. Okay, now I have solved this here. I'll show you and I'll end up this video. So this is obviously type, tell me which type? Type 3, because there is a quadratic, and if you try to use your calculator to solve this as an equation, you'll get imaginary roots. So as I told you before, you assume like this, and you have to multiply throughout by this. How did I get this step? I'll color it for you. How did I get that red color step? Very simple. I'm multiplying throughout by that green thing. Throughout by. And don't forget this bracket, because in exam I see students making very simple mistake by not putting a bracket here, because that will give you an entirely different thing. Can you see? If you do not put bracket, you'll think the numerator will be like this. So don't forget that factor, because I keep on seeing this mistake. Now there is only one good number here, that is s equal to 1, because the remaining will be complex. So I'm putting that cute number over here, s equal to 1, and I got one unknown. Now what will you do? You put random numbers like s equal to 0. If I put s equal to 0, I'll get 4 is equal to 4a plus, this will become c, right? C and minus 1, so 4a minus c. And I know the value of a, so I'll get 4 is equal to 4 minus c, or c is equal to 0. You can solve it once more. I did it very hurriedly. And now you put another number s equal to 1, or you can equate the coefficient, because if you equate the coefficient also, it will be easy. It will be a plus b is equal to 0, a equal to minus b. So you can try it, find a, b, c, and confirm if the value is 0. Practice a lot of question. I'll keep one more question for you, and I'll be back with another video, and in the next video we'll go through convolution method. And after convolution method, we learn the second shifting theorem in inverse, and then differential equation. So now comes convolution theorem, then second shifting theorem in inverse, and then finally differential equation. So till then, my friends, bye.